Okay, so our total area is what? Well, we're going to think of it this way. We're going to take our first interval that goes from y0 to y1, and we're going to partition it with respect to x. And then we're going to do the same for the second interval, third interval, all the way up to our last interval. It goes from yn minus 1 up to yn. And we're going to represent all these areas by a sum. Okay, the total area then will be the sum from I equals 1 to n of the area of the strip. But the area of the strip is then the sum from j equals 1 to m of delta xj times delta y sub I. That I doesn't look much like an I. Now, for every j from 1 to m, I is going to be constant. Okay, at least for every I, we have a sum that goes from j equals 1 to m with delta y sub I just being the same in every sum. So that this can be expressed as a sum from I equals 1 to n of the sum from j equals 1 to m of delta xj multiplied by delta yi. Delta yi. I'm getting my subscripts backwards because very often these things are set up with the x having the I subscript, the y having the j subscript. I'm intentionally not doing it that way, but I keep wanting to use that order. Okay, so there's your total area, which means simply, geometrically, what's this mean? That means, let's look at this strip here. Okay, my delta y is the same for every rectangle in this strip, for every one of these rectangles in this strip. Okay, so for every value of I, I've got all these rectangles. They all have the same, if you wish, the same altitude, where altitude goes this way and width goes that way. And they all have a width. The width of each one is some number delta x sub j. Okay. If we add up all the delta x sub j's, we just get the length of this strip. Okay. And you might think about just why that is. And we multiply the length of the strip by the width of the strip, and what do we get? We get the area of this strip. So that, get the right color chalk here. Okay, this sum of the xj's is just the width of the ith strip. And that's multiplied by what? Delta y sub I is, we'll say the height, I'll just say the length of the ith strip. That's all this represents. Total width of the ith strip times the, I've got width and length used in a way that might be less intuitive than it would be if I switched the terms. So I'm going to, I was wanting width to go that way, but I'm going to call this the length of the ith strip. Just because the same thing appears longer than it is wide, and that will generally be the case. And delta y sub I is what we would normally think of as the width of this strip. Length times width. Okay, so that's what the sum of all the delta xj, delta yi i's is. Now, we're summing this over all strips. So this is a sum from I equals 1 to n. I hate to be that sloppy. Seems that I sometimes can't help myself. This is just the area of the ith strip. So this is the total area. Now I'm exaggerating a little bit. Well, I'll just say the total area of all rectangles of this form, and that's approximately equal to the area of the region. Now there are a couple of little questions that arise the way I've set this up that I didn't want to address here. We're really going to represent each region by a sample point, and I'll get to that in a few minutes, or very shortly. But that's what we have for an approximation of the total area, and the only reason that approximation isn't accurate is because wherever we cut this last strip off, I've got, or this last rectangle, some of that rectangle either goes outside of or stays inside the curve. So we're either getting a little extra area, or we're getting a little, we're missing a little bit of area when we talk about this. So really here we'd be talking about a region that would, kind of look like this and be bounded by this little jagged curve that would extend along the actual curve. Well, we'll talk about that in the next clip.